$1 billion climate innovation fund.
Elon Musk offering a $100 million prize.
We have to use direct air capture and sequestration.
ExxonMobil and a company called Global Thermostat.
What everybody is doing is carbon sequestration. And we at Global Fiber Solutions have been talking, and that's the goal. The main goal is carbon sequestration. And what they don't realize is industrial hemp can help them achieve that goal without spending that much money.
Today, we're also announcing a new $1 billion climate innovation fund to accelerate the development of carbon reductions and removal technologies.
Elon Musk offering a $100 million prize for the best carbon capture technology.
If we're going to solve carbon, we have to use direct air capture and sequestration to take carbon out of the atmosphere and permanently store it in the ground.
ExxonMobil and a company called Global Thermostat announced an expanded joint development agreement to advance and bring to scale breakthrough technology that removes carbon dioxide directly from the atmosphere.
Carbon removal can be done naturally by planting trees or improving carbon storage in the soil through more sustainable farming practices such as crop rotation and improved cattle management. Now, Carbon Engineering is working on building a commercial facility in the Permian Basin with partner Oxy Low Carbon Ventures, a subsidiary of oil giant Occidental. According to Carbon Engineering, once the plant becomes operational in 2024, it will be able to capture up to 1 million metric tons of CO2 per year, which it says is equal to the CO2 that would be removed by 40 million trees, or by taking 250,000 cars off the road.
That in perspective, let's say that we're going to be using the data that some of the people are using out there, saying that we can sequester only 6 tons of CO2 per acre growing hemp in between 70 to 90 days. But I believe if we do a high density, we can achieve more than 10 tons per acre. Let's use the 6 tons example. So if you do 25,000 acres of hemp fiber, or what we call it industrial, you can sequester 150,000 tons of CO2. To reach the million is very easy with industrial.
Carbon capture and removal is getting a lot of attention. The process, which is known as direct air capture, sucks CO2 straight out of the atmosphere. Today, the cost of direct air capture is more than 50 times the cost per metric ton of most natural climate solutions.
Cost estimates for direct air capture really range from about $300 to $800 per ton of carbon dioxide.
For the storage part of the process, Climeworks has partnered with carbon storage company Carbfix. After the CO2 is collected, it's mixed with water to form what's essentially hot seltzer. The mixture is then injected deep underground into a basalt rock formation. When the CO2 eventually mineralizes, it's permanently locked underground. But costs are still high. To capture 1 metric ton of CO2 runs the company between $600 and $800.
With industrial hemp, we can do that for under $100 per ton. Most likely, if we do the whole project, around $25, $30 per ton.
45Q provides a tax credit of up to $50 per metric ton for capturing and storing CO2, and up to $35 per metric ton if the captured CO2 is used for feedstock and things like fuels or for enhanced oil recovery. Today, 25 countries around the world have a national carbon tax, but the US is not one of them.
With the carbon credit alone, it could be almost free. And in this country, we have millions of acres to do that.
Microsoft too has invested.
We bought 1,400 metric tons of CO2 removal. We also went and invested in a new carbon capture facility that they're building in Iceland.
But Microsoft stresses that large corporations also have a part to play.
When you look at really the way that you can incentivize through financial vehicles new markets to develop, there's really 3 legs to that stool: as a customer, as an investor, and as a donor or a philanthropist. And so we're doing the 2 that we really have the power to act on, and every corporation that can do that should do that. Direct air capture is going to be an important part of how we reach a net zero carbon economy, but it has a lot of engineering challenges ahead of it, and we need to be clear-eyed about that. Otherwise, there's going to be a lot of dashed hopes and missed targets as we go from 20 20 to 2030, 2040, and 2050. If you do the math, you have to deploy all carbon removal opportunities to their maximum capacity.
Thanks for watching. Have a great day. God bless you.